Okay, let's dive right into this explainer and set a pretty high-stakes scene. Picture trying to keep a massive telecom network alive in a blistering 50-degree environment where you, the technician, are the ultimate defender. You know, when you look at your phone and see full signal, you probably don't spend a lot of time thinking about the physical infrastructure making that possible. But behind every single flawless connection is a heavily fortified structure fighting off relentless environmental and human threats. So today, we're going to break down exactly how these vital sites operate, and more importantly, the strict rules required to survive them. Here's the game plan for today. First, we'll go inside the fortress. Then we'll cover power and invisible shields, followed by climate control and security. After that, we'll break down the 3 golden rules of survival. Rule 1, unknown cables. Rule 2, high current power. And finally, Rule 3, restricted access.
All right, Section 1. Inside the telecom fortress and the stakes of connection. Let's establish right off the bat that a telecom site isn't just some standard room with servers. It's literally a fortress under constant siege from heat, sand, and lightning. To keep a network running, this place has to be entirely self-reliant.
Section 2, Power and Invisible Shields, Generators and Grounding. We're going to start exploring the anatomy by looking at the heavy-duty backup and the critical safety foundation of the site. If the main power plant is the heart of the operation, these two systems are its survival mechanism and its armor.
Now, battery banks are great for keeping a network alive for a few hours, but it's the generator that ensures survival for days during a massive power failure. But here's the catch. That generator relies entirely on the ATS, or automatic transfer switch. If a site loses power but the generator doesn't kick in, the fault is almost always in this clever little piece of logic, not the physical engine itself. It's essentially the brain that detects the exact microsecond the grid drops and issues the command to start firing.
When you look at these primary survival systems, it's wild how the simplest things can cause absolute chaos. Take the generator. It needs weekly auto-start tests because something as basic as a dead starter battery or contaminated fuel is its silent killer. And then look at grounding, which is your invisible shield. In humid, salty air, like out in the coastal areas of Ajman and Dubai, ground connections can quickly corrode with this green and white crust. If a technician touches a rack and feels a little tingle, that grounding has failed. It means the stray electricity meant to travel safely into the earth is now traveling through the equipment and potentially right through the technician.
So, if you take nothing else away from this part, remember this pro tip. Always connect the ground first. You have to treat the ground wire as a literal life safety issue, making it the very first wire you attach and the absolute last one you ever disconnect. It's the single most important wire in the entire site because it guarantees that if there's a static charge or a massive lightning strike, the equipment and the human being standing next to it are totally protected.
Section 3, Climate Control and Security, HVAC, Access, and Signs. Let's pivot over to the environmental and administrative systems. These act as the vital life support and rigorous gatekeepers of our fortress, because honestly, backup power is completely useless if the site melts down or is left wide open to the elements.
In the intense UAE climate, these cooling components are absolutely critical infrastructure. It's kind of ironic, but a multi-million-dollar network can literally be taken down by a dusty air filter. Telecom equipment generates a massive amount of heat, and ignoring filter hygiene just forces the compressor to work twice as hard until it burns out. Also, professional sites use a lead-lag cooling redundancy. Basically, if the primary lead unit fails, the backup lag unit must automatically take over. If it doesn't, the equipment will start throttling its performance and eventually shut down completely just to avoid melting.
Failing to secure warped doors from the desert heat or ignoring radiation safety signs transforms a perfectly reliable site into a massive liability. Take access control. It's not just about swiping keycards, it's about the physical integrity of the room itself. In remote desert areas, extreme heat can actually warp heavy metal doors. If that seal breaks, sand and humidity just pour right in. And those safety signs? They aren't just legal decorations. When a sign warns of high voltage or dangerous RF microwave radiation, it's warning of actual physical effects, like serious RF burns. You have got to respect the stop zones.
Okay, here's a crucial pro tip. Always document the environment log. Logging the exact temperature when you sign out of a site protects you from being blamed if an environmental failure happens 24 hours later. It is your ultimate professional shield. Think about it. If you leave and the AC compressor fails the very next day, your log is the proof that the site was completely stable when you locked the door.
Moving on to Section 4, Rule 1, Unknown Cables and the Domino Effect. Now that we know the hardware, let's step into the human element and the absolute non-negotiable operational boundaries, starting with cables. You can have the best generators and cooling systems in the world, but human error can bring it all crashing down in seconds.
This rule is absolutely ironclad. Do not disconnect unknown cables. Pulling a mystery cable can trigger a massive domino effect, causing a blind outage for an entire neighborhood or taking down a mission-critical 5G cell. In a telecom site, you're surrounded by hundreds of interwoven fibers and cables. Sometimes the cable looks entirely unused, like it's just hanging there, but it's actually a vital standby line waiting to activate if the primary fails. Pulling it without knowing exactly what it does creates an immediate, untraceable crisis for the network operations center. To prevent that kind of catastrophe, you must strictly follow a 4-step verification checklist before you even think about touching anything. First, you start by tracing the cable using a tone generator, which is often called a fox and hound, to safely identify where it goes without having to unplug it. Then you verify it against the site's map. If it's not on the map, you stop. If you absolutely must disconnect it, you label both ends, and most importantly, you communicate with a NOC to get their explicit approval. And as a quick pro tip, always leave the site better than you found it. Use Velcro straps to organize the cable spaghetti. True professionalism is visible to the next person who walks through that door.
Section 5, Rule 2, High Current Power and the Unforgiving DC. Moving deeper into the danger zones, we arrive at the telecom power systems, where a little bit of overconfidence can lead to a disastrous human-induced outage, or much worse, permanent injury.
Look, DC power is completely unforgiving. Unlike the household AC power you're used to, which constantly crosses zero voltage and trips the breaker easily, Telecom DC provides a relentless, continuous flow of energy with absolutely no fast trip protection. These power plants are built to dump massive, sustained energy to keep networks alive during disasters. So, if you accidentally drop a screwdriver into a bus bar, which is the main copper highway of the power cabinet, the heat generated can instantly weld that tool to the terminals. That causes a severe electrical fire or a blinding arc flash. It is a terrifyingly unforgiving environment.
If you even suspect a power issue, or say you smell smoke, your only job is to observe, read the LED status, and report it. Never, ever try to be a hero with a live battery bank. Unless you have specific power training certification and the right electrical PPE, you are strictly there to monitor. You read the alarm code, whether it's mains fail or rectifier fail, report it directly to the NOC and you step back. Batteries act as massive energy reservoirs. Even if the system looks completely off, they are fully charged and ready to discharge all that energy the second you touch the wrong point.
And finally, Section 6, Rule 3, Restricted Access, Trust and Liability. Let's talk about the strict adherence to access protocols, which protects both the network and your own legal standing. You see, telecom sites are shared environments, often housing highly sensitive equipment from multiple companies or government entities.
Entering areas with toxic battery acid or high-intensity RF radiation without following the strict 3-step protocol will trigger security alarms and basically ruin your professional reputation overnight. First, you must have an approved work order. Second, you have got to call the NOC to check in and announce your arrival. And third, you must verify your restricted zones. Just because you have access to the front door, it doesn't mean you have clearance to enter a subroom with secure servers or step out onto a rooftop with live microwave antennas.
Your badge is your key, absolutely, but it is not an all-access pass. If your badge doesn't work, contact the NOC rather than forcing entry. Remember this, a professional is patient, whereas an intruder is impulsive. These sites are rigged with motion sensors and door contact alarms everywhere. If you try to force a lock or bypass a door just because you think your badge should have worked, you aren't just breaking a rule, you are triggering an automatic emergency response that might literally dispatch the police. Trust is your absolute most valuable currency in this industry.
So the next time your phone connects flawlessly, maybe ask yourself, who is out there braving the invisible fortress to keep that signal alive? Think about the massive, high-stakes infrastructure and the careful human precision operating under a strict code of survival out in the desert just to keep our modern world running every single day. Thanks for diving into this explainer with me.